Hey guys, welcome to the second video in the series on graphs. Today I'm going to be talking about exercises 9C-1 and 9C-2. They're on isomorphic and connected graphs. Okay, so the key knowledge is to be able to identify isomorphic graphs for 9C-1, and then 9C-2 is recognise connected graphs and how they relate to bridges. What do they mean? So these are the key terms you should be defining. Remember that this topic is really important to be writing good notes because there's lots of definitions, and just understanding them is probably the most important thing, not sort of mathematical ability. And then complete these exercises or these questions from 9C-1 and 9C-2. That should say 9C-2, 1AC, 2AC, 3, 4, 5. Okay. So, first question here is, what does isomorphic mean? Okay, so what I'm going to do is, I might just define it. Isomorphic, just for all intents and purposes means equal or the same. Okay, but same is really important. It's the same degree vertices, okay, and same connections. Okay, so isomorphic graphs are said to be isomorphic or equivalent if they have the same number of vertices and edges, and their corresponding vertices have the same degree and same connectivity. So I'll show you what I mean. So believe it or not, all three of these graphs, 1, 2, and 3, are isomorphic, meaning they're actually the same graph. They've just been distorted, or they've been stretched in a way which the shape is now different, but the same connectivity applies. So A has degree 2, because it's got two connections, 1, 2. D has degree 3, B has degree 2, C has degree 3. Okay. In graph 2, A has degree 2, C has degree 3, D has degree 3, B has degree 2. In graph 3, A has degree 2, C has degree 3, D has degree 3, and B has degree 2. Okay, and if you look carefully, they're all the same. They're all got the same degree. They're all the same number of connections. Now what we need to do is check that they're connected in the same way. Okay, so if I look at A is connected to D and C in the first one. So in the second graph, A is connected to C and D, so that matches up. In the third one, A is connected to D and C, and that's the only way they're connected in all three graphs. So that's working out well. B is connected to D and C in graph 1. B is connected to D and C in graph 2. B is connected to D and C in graph 3. And if you kept going in that way, you'd find out that they are isomorphic. All that's happened is that this has just been stretched. So imagine if you take vertex A and bring it down the bottom like that, it will look like graph 3. Okay, so they're isomorphic, same connection, same degree. Okay, these graphs here are not isomorphic. Okay, and it would probably be beneficial to you to stop the video and try and work out why on your own. Okay, but I'll show you why now. If I look at the degrees, A has degree 2, B has degree 2, D has degree 3, C has degree 3. A in this one has degree 3, C has degree 2, D has degree 3, and B has degree 2. And so you can immediately see, I'll just change colours, that A here and A here, they're different. 2 is not equal to 3. So these 1 and 2 cannot be isomorphic because they've already got vertices with different degrees. Okay, if we compare graph 1 and graph 3, in graph 3, A has degree 3. So again, 2 does not equal 3. 1 and 3 are not isomorphic. Is graph 2 isomorphic with graph 3? Okay, well A has degree 3 in both of them. Let's see what D has. We'll see D has degree 2 here and degree 3 here. So I can see that because they don't match, they're not isomorphic. They're not equivalent. So they're not equivalent in this case. Okay, so that's basically 9C-1, being able to recognize that. Same connectivity, same degrees. Okay, and do they match? They're the same graph, they're just a different shape. Okay, 9C-2 is connected graphs. Okay, so I might just define that now for you. A connected graph, connected graph means every vertex can be reached by an edge. So a good way of thinking about it is, if I start somewhere on a graph and I go for a little walk in the graph, can you get to every single vertex? And you see here that you can't in this one. You can't in this one either, because there's nothing connecting B and D. You can't in this one because these two vertices are disconnected from these two vertices. Okay, so connected means that you can get to every vertex. Okay, this graph is connected. Okay, because I can get to every single vertex. I can go on a walk like that. I might have to go back on myself a bit, but I can get to every vertex. These are disconnected because they have basically vertices which are out by themselves. You can't get to them when you're going on a walk. Okay, so connected, disconnected. The last thing to learn about is a bridge. Okay, so what is a bridge? That first question. A bridge basically is an edge that, if removed, leaves the graph disconnected. Okay, so if I was to go, I'm going to erase this. Okay, get my red. In this graph, the bridge in this graph is this one here. Okay, because if I was to remove this edge, all of a sudden you have these vertices here disconnected from D. Okay, so that is a bridge. Okay. In this graph here, graph 1, if I was to make an edge between B and C, that would be the bridge. Okay, because if I removed it, it would be a disconnected graph. Okay, so it's really that simple. Connected graphs, all the vertices connect. If you go on a little walk, you can get to every single vertex. A bridge is a single vertex, which if you remove it from the graph, it leaves the graph disconnected. Okay, so remember, same deal applies. Draw all graphs. Okay, for you to be complete. Okay, and you need to complete 9C-1 and 9C-2, please. Okay, those exercises. Good luck.